Hello everyone. In this short video, we're going to focus on types of data, also known as levels of measurements. Before we get started, I would like you to think about one question. Why do we need to classify data into different types? This is important because before we describe or analyze data, we need to understand what kind of data we have collected. In psychology and social science research, data can come from many sources. We might collect data using questionnaire, behavior tasks, or instruments that measure things such as reaction time, height, temperatures, or test scores. We may also convert some information into categories, such as grouping participants by condition, diagnosis, or education level. However, not all data work in the same way. Some data are simply categories. Some data have a meaningful order. Some data are numerical, but the 0 point does not mean the complete absence of the things being measured. Other data are numerical and have a true 0 point. We will discuss these differences in more detail in this video. These differences matter because they influence how we summarize the data, how we present the data, and what kind of statistical analysis might be appropriate. For example, imagine we want to explore whether anxiety is related to sleep quality. If both anxiety and sleep quality are measured using numerical scale scores, such as scores from 0 to 6, this may allow us to consider analysis that examines relationships between two scores. For example, we might say people with higher levels of anxiety tend to report lower levels of sleep quality. However, this is different when one of our variables is categorical. Using anxiety and sleep again, we may ask whether people who report sleeping problems, for like yes or no, tend to have higher anxiety scores than people who do not report sleeping problems. In this case, sleeping problems are measured as a categorical variables because the type of data is different. The way we analyze the data may also need to be different. This is only a basic idea at this stage, but the key point is this. The type of data helps guide the way we describe, display, and analyze our results. In this session, we will focus on four main types of data. These are nominal, ordinal, interval, and ratio data. First, let us begin with nominal data. Nominal data are data made up of labels or categories. The key point is that the categories have no natural order. For example, nationality is nominal because categories such as British, Taiwanese, French, or Spanish are labels. They're not ranked from low to high. And religion can also be nominal because categories such as Christians, Muslims, Buddhists, or no religion are labels rather than order scores. Experimental condition can also be nominal, such as control groups versus a treatment group. A common point of confusion is that nominal categories may sometimes be coded using numbers. For example, we might code control group as 1 and treatment group as 2. However, these numbers are only labels. They do not mean that the treatment group is more than the control group, and they do not mean that 2 is twice as much as 1. The numbers are simply convenience codes that allow softwares such as SPSS or R to store and to analyze the information. So, for nominal data, the important question is this. which categories does this person or observation belong to? There is no ranking or no numerical distance between categories. Now, let us move on to ordinal data. Ordinal data are also categorical, but the categories have a meaningful order. This means that we can rank the categories from low to high, or from less to more. For example, education level can be ordinal. In the UK system, we might have GCSE, A levels, undergraduate degree, master degrees, and doctorate degree. These categories have a meaningful order because they represent increasing levels of education. Another common example is lectures response options, such as strongly disagree, disagree, neutral, agree, and strongly agree. Pen ratings such as low, medium, and high are also ordinal. The key feature of ordinal data is that we know the order, but we cannot assume that the spacing between categories is equal. For example, can we say that the difference between an undergraduate degree and a master degree is exactly the same as the differences between a master degree and a doctorate degree? No, we can't. We know that these categories have an order, but we cannot say that the distance between each level is exactly equal. Similarly, can we say that the difference between strongly disagree and disagree is exactly the same as the difference between disagree and neutral? Again, no. We can say the responses are ordered, but we cannot be completely sure that the psychological distance between each response option is equal. This is why ordinal data are more informative than nominal data because they include order, but they still have limitations. We can say one response is higher or lower than another, but we should be careful about assuming equal distance between the categories. At this point, it is also useful to classify the word level. In research methods, we sometimes use levels of measurement to refer to nominal, ordinal, interval, or ratio data. However, within a categorical variable, we also sometimes use the word levels to mean the categories of that variable. For example, if experimental condition has a control group and a treatment group, those are the two levels of that variable. So the same word can have slightly different meanings depending on the context. Now, let us move on from categorical data to numerical data. We will start with interval data. Interval data are made up of ordered numbers with equal units. This means that the difference between two values is meaningful and consistent across the scale. A common example is temperature measured in degrees Celsius. The differences between 10 Celsius degree and 20 Celsius degree is the same size as the difference between 20 Celsius degree and 30 Celsius degree. In both cases, the difference is 10 degree. Some standardized psychological scale scores may also be treated as interval data in practice. Earlier, we mentioned that lectures response options are ordinal. Strictly speaking, a single lectures item, such as one question asking participants to rate agreement from strongly disagree to strongly agree, is ordinal. This is because the response options are ordered, but we cannot be completely sure that the distance between each option is equal. However, in practice, researchers often use several lectures items together to create a total or average score. For example, a depression questionnaire or anxiety questionnaire may include several items or questions, and each item may be scored from 1 to 5, with 1 representing strongly disagree and 5 strongly agree. Researchers may then calculate the total score or the mean score. When several items are combined in this way, researchers often treat the overall scale scores as approximately interval. This allows them to report mean and standard deviation and to use statistical analyses that are suitable for numerical data. However, we should remember that this is a practical decision. We are not saying that every lecture item is automatically interval. Instead, we are saying that combined scale scores are often treated as approximately interval in psychological research. The key point about interval data is that equal differences are meaningful. However, the 0 point is not a true zero. In other words, 0 does not mean the complete absence of the things being measured. Temperatures in Celsius is a useful example. 0 degrees Celsius does not mean that there is no temperatures. It is simply a reference point on the scale. So, why do we need to distinguish whether a variable has a true zero or not? The reason is that it affects whether we can make meaningful time-as-much comparison. For example, it is not correct to say that 30 Celsius degree is twice as hot as 15 Celsius degree. Although 30 is mathematically twice 15. The Celsius scale does not have a true 0 point. Therefore, this ratio comparison is not meaningful. Another example is an IQ score. If someone has an IQ score of 120 and another person has an IQ score of 60, we should not say that the first person has twice as much intelligence as the second person. The scores may show a difference, but the scale does not have a true 0 point that means no intelligence at all. This idea of true zero is very important because it affects how we interpret numerical comparisons. If a scale does not have a true 0, we can talk about differences, but we should not talk about one value being twice or half of another in a meaningful way. Now, let's move on to racial data. Racial data have all the properties of interval data, but they also have a true and meaningful 0. This means that 0 represents none of the quantity being measured. Examples include age, reaction time, height, weight, income, and temperatures measured in Kelvin. For age, 0 means no age has passed since birth. For reaction time, 0 would mean no time has passed. For income, 0 pound means no income. Because these scales have a true 0 point, racial comparisons are meaningful. For example, 200 pounds is twice as much as 100 pounds. A person who is 20 years old is twice the age of a person who is 10 years old. The reaction time of 800 milliseconds is twice as long as a reaction time of 400 milliseconds. These twice as much comparisons are meaningful because the scale has equal units and a true 0. So, The main difference between interval and ratio data is the 0 points. Both involve ordered number with equal units, but only ratio data have a true 0. This is why we can make ratio statements for ratio data, but not for interval data. Now, that we have covered the 4 types. Let us briefly compare them. Nominal data are categories with no natural order, for example, like nationality or experimental condition. Ordinal data are categories with a meaningful order, but the spacing between categories may not be equal. For example, lecture responses or education level. Interval data are numerical data with equal units but without a true or meaningful 0. Temperatures in Celsius is a classic example. Some combined psychological scale scores may also be treated as approximately interval in practice. Ratio data are numerical data with equal units and a true 0. Example like age, height, weight, income, and reaction time. Understanding these differences help us decide how to summarize data. For nominal data, we often report frequencies and percentage. For example, we may report how many participants were in each experimental condition. For ordinal data, we may also use frequencies and percentage. We may sometimes report the median because the categories are ordered. In some cases, especially when using combined lecture scale scores, researchers may also report means and standard deviation. For interval and ratio data, we often report means and standard deviations, particularly when the data are approximately normally distributed. This also affects graphs. For nominal and ordinal data, bar charts are often appropriate because we are showing categories. For interval and ratio data, histograms, box plots, or line graphs may be useful, depending on the research question and the design of the study. To conclude, before you describe or analyze data, always ask yourself 4 questions. First, are the values just category labels? If yes, the data are likely to be nominal. Second, do the categories have a meaningful order? If yes, the data may be ordinal. Third, are the values the numerical with equal interval but without a true or meaningful 0? If yes, the data are interval. The last question, are the values numerical with equal interval and a true or meaningful 0? If yes, the data are ratio. Once you can identify the type of data, you will be in a much stronger position to choose appropriate summaries, graphs, and analysis. This is why understanding data types is a foundation for good research practice. Thanks for watching. I hope you found this video useful.